Imagine a place where gravity reigns supreme, a force so intense not even light can escape its grasp, a black hole. It's a region of space-time from which nothing, not even light, can escape after having fallen past the event horizon. These are not empty voids, desolate and barren, but the collapsed remnants of massive stars. Stars that lived fast and died young, matter crushed into an unimaginably small space, a point of near-infinite density. Black holes challenge everything we know about space, time, the very fabric of reality, and the laws of physics as we understand them. They push our understanding to the absolute limit. Their story begins with the death of a giant star, a cosmic behemoth, far more massive than our sun, dwarfing it in both size and power. When such a star runs out of fuel, after burning through its hydrogen, helium, and heavier elements, its core collapses, unable to withstand the immense gravitational forces triggering a supernova explosion, a spectacular display of cosmic fireworks. If the remnant is heavy enough, if it exceeds a critical mass, gravity crushes it into a singularity, a point of infinite density, and infinitely small space. At the heart of every black hole lies this singularity, the ultimate cosmic mystery, where the known laws of nature break down, where our understanding of the universe falters. Black holes are cosmic extremes, the ultimate test of our physical theories, where reality itself is pushed to its limits, where space and time become warped and distorted. They're not just monsters lurking in the dark, silent and menacing, they're laboratories for the universe's wildest experiments, pushing the boundaries of what's possible. The quest to understand black holes, to unravel their secrets, is a quest to understand the universe itself, its origins, and its ultimate fate. So, let's embark on a journey, a voyage of discovery, to the edge of space and time, to the very boundaries of our knowledge. We'll explore what black holes are, their fundamental properties, what they do, how they interact with their surroundings and the mysteries they hold, the questions they pose about the nature of reality. Could they be portals to other places or times? Could they be shortcuts through the cosmos? Could a black hole ever grow large enough to swallow everything, to consume all matter and energy, even the universe? Is there a limit to their growth, or could they eventually dominate the cosmos? The answers might surprise you, challenging your preconceived notions about the universe. They might change the way you look at the night sky forever, filling you with a sense of wonder and awe. Come with me, and let's explore these cosmic enigmas together. Let's step into the unknown and unlock the secrets of the universe's ultimate mystery. To truly grasp the nature of black holes, these enigmatic cosmic entities, you first need to fundamentally rethink your understanding of gravity. Forget what you think you know. Einstein revolutionized our perspective, showing us that space and time are not separate entities but are instead woven together as space-time, a single unified four-dimensional fabric that permeates the entire universe. Picture space-time as a vast, stretched rubber sheet, an invisible canvas upon which the cosmos plays out. Now, place a heavy ball on it, representing a massive object like a star or a planet, and the sheet curves and warps around the ball, creating a dip. That curve, that distortion of space-time, is what we perceive as gravity. Massive objects bend space-time, creating pathways, and we, along with planets and stars, simply follow those curves, tracing the contours of gravity. Now imagine a black hole. It's like a weight so incredibly heavy, far beyond anything we can easily comprehend. It punches a hole straight through the fabric of space-time, creating an infinitely deep well. Its gravity is so intense, so overwhelmingly powerful, the curvature becomes infinitely deep, a gravitational well from which absolutely nothing, not even light, can escape its grasp. Light passing near a black hole bends dramatically, warping and distorting our view, creating a cosmic lens effect. This warping of space-time doesn't just affect space and the path of light, it profoundly distorts time itself, bending it in unimaginable ways. The stronger the gravity, the more intense the curvature of space-time, and the slower time flows relative to a region of weaker gravity. This phenomenon is known as time dilation, a mind-bending consequence of Einstein's theory. We see this effect in action every day with GPS satellites orbiting our planet, which need constant, precise adjustments to their atomic clocks because time moves ever so slightly differently for them in their orbit compared to us on the ground. But near a black hole, this effect is amplified to an extreme degree. Time slows dramatically, almost to a standstill. To a distant observer watching something fall into a black hole, a falling clock appears to slow down and eventually freeze at the event horizon, the point of no return. But for the clock itself, experiencing its own passage of time, time continues to feel perfectly normal, ticking away as it always has. This disconnect, this difference in perception, is a fundamental feature of our universe. Time is not absolute but relative, dependent on your position and motion within the fabric of space-time. Black holes, therefore, are the ultimate time-warping machines in the cosmos, pushing the boundaries of physics as we know it, stretching time to its breaking point, revealing the bizarre and counterintuitive nature of reality. They show us, in the most dramatic way possible, that reality is far stranger, far more complex and far more mind-bending than our everyday experience might lead us to believe. The familiar comforting rhythm of time, the steady beat of existence, is shattered at the edge of a black hole, revealing the fragility of our perceptions. Here, at the event horizon, the fundamental rules of the cosmos are rewritten, challenged, and pushed to their absolute limits. And the journey into the heart of a black hole, into the unknown depths of space-time, only gets weirder and more perplexing from here. So buckle up and prepare to have your mind blown as we delve deeper and see just how strange, how utterly bizarre it can truly get. The way black holes bend space-time has led physicists to wonder, could they be gateways, even time machines? When scientists solved Einstein's equations for a rotating black hole, they found a ring-shaped singularity. The math suggested a possible tunnel, a wormhole connecting distant points in space. Imagine folding our rubber sheet of space-time and punching a tunnel through a shortcut across the cosmos. Some theories even hint these tunnels could link different times, not just places, but there are problems. We've never seen a wormhole, and if they exist, they'd likely collapse instantly. To keep one open, you'd need exotic matter with negative energy, something purely theoretical. Even if you could survive the journey, the intense forces near a black hole would make it nearly impossible. So, could black holes be time machines? Probably not. But the idea shows how black holes push the boundaries of what's possible. They're not just cosmic destroyers, they're windows into the wildest corners of physics. And they keep us asking, what if? Every black hole is surrounded by an invisible boundary, a sort of cosmic veil. This boundary isn't a physical barrier you could touch, but rather a region in space-time. We call it the event horizon. It marks the point of no return. It's not a surface in the traditional sense, but a one-way door in space-time, a gateway to the unknown. Imagine a waterfall, but instead of water, it's the very fabric of reality flowing inward. Cross it, and escape is impossible. Once you've passed this threshold, there's no turning back, no matter how powerful your rocket. The gravity here is so strong, not even light, the fastest thing in the universe can get out. It's trapped, forever orbiting or pulled into the singularity. If you fell in, your friends, watching from a safe distance, would see you slow down and freeze at the edge, fading away as time itself seems to grind to a halt from their perspective. This is due to the extreme time dilation near the black hole. But for you, time would feel normal, at least initially. You wouldn't perceive any slowing down. As you cross the horizon, unaware of the exact moment you pass the point of no return, there would be no alarms, no flashing lights, just a smooth transition. Soon, however, you'd experience spaghettification, a rather unpleasant effect of the black hole's intense gravity. The tidal forces, the difference in gravity between your head and your feet, would stretch you into a thin strand, like spaghetti. You'd be torn apart long before reaching the center, atom by atom, molecule by molecule. The singularity awaits, a place where space and time end, where our current understanding of physics breaks down completely. From your perspective, the outside universe might flash by in an instant, an accelerated glimpse of its entire future. Your mass would be added to the black hole, increasing its size ever so slightly, your story ending in the ultimate abyss, a region of complete darkness and unknown physics. The event horizon is the point of no return, the ultimate boundary, a one-way trip to oblivion, a journey from which nothing can ever return, nothing escapes, not even information, leading to what's known as the information paradox. It's the ultimate cosmic trap, a gravitational prison from which there is no escape. And it's one of the universe's most mysterious frontiers, a place where the laws of physics as we know them cease to apply. What happens inside remains one of science's greatest questions, a puzzle that continues to challenge our understanding of the cosmos. Black holes aren't just static, they're hungry, growing by devouring anything that comes too close. As matter spirals in, it forms a superheated accretion disk, glowing with X-rays. Some black holes become quasars, outshining entire galaxies. These are powered by supermassive black holes millions or billions of times the sun's mass. Nearly every large galaxy, including our Milky Way, has one at its core. As black holes feed, not all matter is swallowed, some is blasted out as jets, stretching for thousands of light years. These jets can reshape galaxies, sterilizing regions and halting star formation. Black holes are engines of chaos, tearing stars apart and blasting their surroundings. The more they eat, the bigger and more dangerous they become. Their appetite seems limitless. So, is there any limit to how big a black hole can get? If a black hole can eat a star, why not a galaxy? As supermassive black holes consume stars and gas, their influence grows. Galaxies collide and merge, and so do their central black holes, creating even larger monsters. We've observed these mergers, even detected their gravitational waves. The largest black hole we know, Ton 618, has a mass of 66 billion suns. Our entire solar system could fit inside its event horizon many times over. As long as there's matter to consume, a black hole can keep growing. In theory, it could swallow its host galaxy, then neighboring galaxies, and eventually dominate a supercluster. The cosmic feast could lead to a universe ruled by a few titanic black holes, but could this process go on forever, or is there something that stops even the biggest black holes? The answer lies in the fate of the universe itself. Let's find out. What's inside a black hole? Physics says a singularity, but some propose a radical idea. What if matter falling in rebounds, creating a new universe on the other side? Our own Big Bang might have started as the collapse of a black hole in another universe. Black holes could be seeds of new universes, each with its own laws of physics. This cosmic tree idea suggests universes branch off from black holes endlessly. It could explain why our universe is so well tuned for life. Universes that make more black holes create more offspring. While unproven, it transforms black holes from destroyers to creators. The end of one universe could be the birth of another. It's a profound shift in perspective. Black holes might be engines of cosmic rebirth. Could a black hole swallow the entire universe? The universe is expanding, and that expansion is accelerating, driven by dark energy. For a black hole to consume everything, its gravity would have to overcome this expansion. But even the largest black holes are limited to their local neighborhoods. Galaxies beyond our local group are receding too fast to ever be caught. So, in our current universe, the answer is no. A black hole can't swallow everything. Instead, the cosmos is headed for a big freeze, where galaxies drift apart, stars die, and black holes slowly evaporate. But there's a wild card we don't fully understand: dark energy. If it changes, a big rip could tear everything apart, even atoms. In that case, the universe would end, not by being swallowed, but by being ripped to shreds. The fate of everything hangs on the mysteries of dark energy. For now, the universe's expansion keeps us safe from cosmic consumption, but the story isn't over. The universe always has surprises. So where does this leave us? We live in a universe filled with wonders and mysteries, black holes chief among them. They are the ghosts of dead stars, engines of galactic change, and maybe even seeds of new universes. Black holes bend space-warp time and challenge our understanding. Our knowledge is just a small island in a vast cosmic ocean. The story of black holes is the story of our quest to understand the universe. We build telescopes, launch probes, and listen for gravitational waves, all to peer deeper into the darkness. Every discovery reveals a universe stranger and more beautiful than we imagined. Will a black hole swallow the universe? Probably not, but asking the question pushes us to think bigger, to wonder about our origins and destiny. We are stardust, animated by curiosity, living on a tiny planet in an immense universe. The journey has just begun, and the cosmos awaits.